Hello guys, welcome to my channel and let me introduce myself first. So my name is Annawal and I am from Tripura, Sohibat in third year doing BTech in CS. So without any much further delays, let's start with the question. So the question is from code forces and wait a second just. Yeah. So question is from code forces that is scoring subsequences. The score let us read the question now. The score of a subsequence S1 up to SD is defined as S1 into S2 into up to SD divided by d factorial. So where d factorial is 1 into 2 into up to d. In particular, the score of an empty subsequence is 1. That is a factorial property actually. That is empty subsequence. That is 0 factorial is always 1. For a subsequence S1, S2 up to SD, let M be the maximum score among all its subsequences. Its cost is defined as the maximum length of subsequence with score of M. You are given a non-decreasing subsequence, okay, of integers of length n. In other words, the conditions this is satisfied. So for each k equal to that, this, and that, find the cost of a1 up to ak. A sequence x is a subsequence of a sequence y if x can be obtained from y addition of several possible zero or all elements. So let me explain what is the question is saying. So we have like what is that we have a subsequence. So what is subsequence first or sequence first? So let's suppose we have an array, and if we remove some of the elements or possibly zero, let's suppose if we have a1 up to an elements, and I have removed a2 or a3 and then a6 element, and the rest of the element that we have left out, they have to be in the same order. Then that is a subsequence. That is A1, A4, and A5, and then it's up to that. That is a subsequence. And even A2 and A4 is also a subsequence. So after removing some of the elements, then the same order if it maintains. So it's a subsequence. So we have a subsequence and its score will be calculated as by this formula. That is S1 into S2 up to SD divided by d factorial. So, for a sequence, let's suppose S1 to SD, let M be the maximum score among all its subsequences. So we have some subsequence. We have some sequence, and let's suppose we have taken out the subsequence of that sequence, and if the maximum value that we can get, that is the maximum score that we can achieve, is M. Let's suppose that is M. So the cost that is defined for that M for that it will be the maximum length of that subsequence. Let's suppose we have A1, A2, A3, A4. So for A1 and A3, the score is maximum. That is A1 into A3 divided by 2 factorial. The value is M. So the cost will be 2 since we have taken 2 elements so far. That is the maximum length we have to find out. So that is the thing that is saying that is we have to do. This is the main thing. It is non-decreasing sequence. So it is in a sorted way and it is in an increasing order where A1 can be will be can be lesser than or equal to A2. That is up to that. So we have this is the main thing for the entire question. In other words, that I've already told you. And for each k, that is for first element, then prefix that is up to prefix of two, then prefix of three. For up to n, we have to find out the maximum cost, like the maximum cost that we can get. That is the cost of that sequence for up to k. So let's read the input. So we have some test cases. Okay, that is 10 to the power 4 up to 10 to the power 4. We have some n, and that is the length of sequence, and the element inside that array that is non-decreasing order, and it is can be 5 into 10 to the power 5. So output will be the cost of sequences. We have to find out for each and every for each and every prefix. It is 1, 2, 3. That is k from the starting index. So this question has two approaches, like as a one of the approach is mine and one of the approach I've seen to the editorial. So let's move to the like how we will do this question. So First of all, I already said that the main thing is non-decreasing subsequence. This is the main thing for the entire question. If you can get any intuition, like if you can get any intuition from this, so I think you will able to solve the problem. So let me take the input cases. Wait a second. Uh, yeah. So first of all, what is the main thing? Let's suppose what the question is saying to do. Let's suppose there is one, two, and three. For k equal to one, what is that? Wait a second. Wait a second. Yeah, from here. So for k equal to 1, this is a subsequent, that is one that we can get. And the score that we can achieve is 1 upon 1 factorial, that is 1. And that is the maximum. So total length of this is 1. So the answer we will put output that is 1. Then k equal to 2, that is index 1 to up to index 2, all the elements. Then we will take subsequences. So what can be the subsequence so far? That is, it can be 1, it can be 1, 2, it can be 1, 2, or 2 or 1, 1. So 1 divided by 1 factorial, that we always value that we have calculated, that is always give us 1. What if we have taken 1 and 2? So 2 divided by 2 factorial, that is also 1. So that then we take 2. So 2 divided by 1 factorial, the answer will be 2. And that is the maximum so far that we can get. That is the m. And the cost will be for this one is 1. Then k equal to 3. That is 1, 2, 3. That is this part. So we can choose 1, then 1 or 2, or 2 alone, or 1, 2, 3, and then 2, 3, and all subsequences. And then we have found that if we choose 2 and 3, sorry, as a subsequence, so 2 into 3 divided by 2 factorial, that is 3. And if we choose only 3, that also 3. That is the maximum so far that we can achieve. Sorry, that is the maximum so far that we can achieve. And that is the m. So where is the m is maximum? That is the cost that can be get the maximum. Is from here that because we have two lengths, that is 2 and 3. But here it's one length. So we will output 2. So this way, like we will solve this question like the idea that we can get. Sorry. So now, like we know that k equal to 1 for k equal to 2 and then k equal to 3. So how can we think now? First of all, it's a non-decreasing non-decreasing array. So it means that at AI, let's suppose at AK, it can be lesser than or equal to AFK or plus 1. Sorry, it doesn't. Yeah. So where was I? Yeah. So if let's suppose AFK, it's a non-decreasing, so it means AFK will be lesser than or equal to AFK plus 1. And we have find out up to A1 to AFK the maximum. Then when we reach to AFK plus 1, okay. So it will be like if we choose the whole, let us suppose if we choose the whole survey, A of K, A of K minus 1, up to A of 1. Or in a better way to explain this, let's suppose K is equal to 4. So like, let's suppose K equal to 4. So it means A1, A2 into A3 into A4 up uh, divided by whole 4 factorial. One thing is to be noted that to get the maximum value, we will always try to take the maximum element so far, that is A4, in our subsequence. We will try to take over the maximum value, and we will always try to divide it with some minimum value. Why I'm saying this? Because here 4 factorial will be represented as, let's suppose, A1 into A2 into A3 into A4. Oh, wait, into A4. So divided by 1, divided by 2, divided by 3, and then divided by 4. Because A4 is the maximum value and we want the maximum value so far. So we will try to divide it by some minimum value to get the maximum output so far. Even though overall you will say that it doesn't matter at all because after all this will be x and this will be some uh, what would it be 4 0 12 12, 24 that is 4 factorial. So it will be a unified value even though it is a unified value, but for our perspective, what if we have chosen this subsequence? So overall, this would be divided by 3 factorial. If we have chosen this, wait, what if we have chosen this one, this subsequence, or if we have chosen this subsequence, or what if we have chosen this subsequence? So from this way, 4 will be divided by with the minimum value, that is a1, and the maximum value will always be divided by the minimum value. And we will try to take all the maximum values in our subsequence. So from here, that what we got is a4 will be that is the maximum value will be divided by the minimum value, that is 1, and its previous value will be divided by the uh, greater than that, that is divided by 2, and then a2 will be divided by 1, sorry, 3, and then a4 will be divided by the maximum. Now, from here we got that the maximum value will be divided by the minimum value. Okay. Now what, so like we get two things: maximum value divided by the minimum value, and we always take the maximum value subsequence in our subsequence. Now, like which one to choose? We have like which subsequence will we choose? Like this one or this one or this one. So it will be dependent on like what if a4 is 1, so 1 divided by 4 will be gives us about floating value that is 0.25, and this 0.25 will decrease our value. Let's suppose 1, 2, 3, and then 4. Yeah. So 1 divided by 4, 2 divided by 3, 3 divided by 2, 4 divided by 1. So what if these value is like lesser than 1? So we will not try to choose them because these will not like output us at least more than a4 value. That is, this will be gives us 2 divided by 12, that is 1 by 6, that is lesser than 1. And lesser than 1 will not gives us minimum to maximum lesser than that is 4. So we can't choose this. So we will choose those number that is greater than or equal to 1, that is 3 but divided by 2, that is 1.5 into 4. Wait, wait a second. Yeah. So 1.5 into 4 we will choose that will give us 6. And the maximum cost we will get, and this is our m, and the maximum cost that we get is 2. So here we can think like, yeah, so with those one that gives us greater than or equal to 1 will be our value, that is m, that can gives us the overall m, and from here we can find out the cost. So now you get the idea. So this idea can be done in two ways. One of the ways is by using binary search, that is the editorial is saying, and one of the approach is two pointer, the ID that I have used. It will be order of n, and this one will be order of n log n. So first of all, let's go with binary search. So what is the binary search? Is like how can we approach? So let us suppose up to A4, that is A1, A2, A3, and up to A4, we reach. And then we have it in a sorted increasing order. And when we try to find out the mid value, and if the mid value is greater than or equal to 1, if the mid value is greater than or equal to 1, so like what, up to A2, this we will know that it will be divided by 3. So VD is the mid value, and then we will try to divide it by like what is the we have to divide. I mean that uh, I will explain it more clearly. Wait. That is A1, that is A2, that is A3, and that is A4. So wait a second. Yeah. So we know that this one will be take 4, 3, and then 2, and then 1. So we move to the let 0, and this one is 3. So 0 plus 3 divided by 2, and that is this index. So this one A2 was your wait. A2 was your 2. So 2 divided by that is 2 is lesser than 3. So we cannot choose this since it will gives us a value that is lesser than 1. So we will change our start pointer to A3, and then we will try to find out the mid value. So the mid value will be 2 plus 3 divided by 2, 5 divided by 2, that is 2. That is this one. And A3 was your 3. So 3 is greater than 2, so we will choose this, and then we will try to change our end, that is the last pointer, that is this was the last pointer that was earlier, to here, that is last minus 1, then it would be at here, that is last equal to mid minus 1. Since start is lesser than or equal to that binary search algorithm, that is property, so we will stop at here. So we get the mid value, and then from here we will find out the value that we can get, that is overall, the overall value that we can get. So here, this way we can use the binary search. So from here to here, this one will give us a subsequence that we will choose. You can use the prefix sum, sorry, prefix product, and I don't know, like, yeah, you can use that because I have that knowledge about what we have to do. Then I know that I will do this question from binary search. So now you will do what, like, how we can do this problem. Now we will move to the second approach that I have used. The second approach is two pointers. So two pointers is like, let us there is array A1, A2, A3, A4, A5, and here are some values. So here L equal to 0 and R equal to 0, that will point these two. That is two pointer. You can say window. I think yeah, the this is what we name, like I forget, like window size or something like window program, or you can say. So we are at A1. So we are at A1, that is L equal to 0 and R equal to 0. Then we will check is A1 greater than 1 or not. It says yeah, it is greater than 1. So this is the our value. Then we will move R, that is R plus plus, that is up to A2. Then we will check is A1 greater than 2 or not. If it is greater than 2, then again we will move R plus plus. That is at here. So we will reach at this pointer. We will reach to this pointer. And this is our L at, and this is our at L, and this here we are at here R. So we will again check is A1 greater than 3 or not. We found that it is not greater than 3. So we will move our L plus plus to A2. Since this can now never give our answer for up for our up case, because if A1 is not greater than, if A is not greater than 3, so it will also not greater than 4. Now we will check is A2 greater than 2, that is its index. So we found that we found that it's also not greater than 2. So we will move to A3. Then we will find the value. The same we will do, and then we will output our answer. So this is the way that we will use the window, I think the algorithm we call, or two pointers. I hope you get like what we will use, the intuition behind that. Let us move to the code. So it would be end up in order of n-time complexity. So we will take input, that is n, then vector we will store, that is take v, that is c in we have done. So int l equal to 0, and this one is r. So for I equal to 0 to I less than n, I plus plus, while L is less than that, like while L is less than or I, then V of L, that is this. Let me explain this. So if L is less than I, so first of all, L should be less than I. And v of L should be less than I minus L plus 1 that we have done. That is A2, wait, let's suppose A2, A3, and then A5, and then A4. Let's suppose R was at here and L is at here. So R minus L plus 1, that is a total distance. That is 1, 2, 3, and then 4. So we'll check is A2 greater than 4 or not, greater than or equal to 4 or not. If not, then we will just move and then the same procedure. So this is what we have done, that is L plus plus. So we will output our the length, that is I minus L plus 1, and then we will see out input. So this is the way that we can approach this question. I hope you get it and I have explained it way much better. So if you have any doubts, so put that in the comments and I will see that and explain it there too. So that's from my side and bye.